Hi, I'm Paul Brodie. We're in my shop. Welcome back. If you're just joining us, we're a pretty friendly place here. I'm the fabricator. I do stuff. And there's a man behind the camera. His name is Mitch. Very important role. So, we ended up, and I had a block of aluminum, and I was making something, and this is what we ended up with. I'm going to give you a little bit of a slideshow because Mitch was gone. He said something about going out for coffee or something, and then he was gone for over 3 days. So I got busy in my shop and I made a lot of chips. This weighed, it was a block of aluminum. It weighed almost 6 pounds, and now it weighs less than half a pound. So I took off 5.5 pounds of the block. So we're going to do a little slideshow, and then I'll show you how it all fits up here, okay? I held the case up on the mill. I took an indicator. I dialed in so that I knew that the spindle was concentric with the bearing. And then I bolted on the plate. It's not fully machined yet, but it was enough so that it would bolt onto the crankcase. And then I bored out the hole. Here's me taking off more metal on the mill. I've got a 1/2-inch end mill there. And now I've got it up on end, and I need to make the hole, it's a square hole where the chain tensioner goes. So that's what I did here. I held it up there and I used a tool. I want to show you the tool I use. It's a drill bit basically, and I've cut most of it off. It used to be this long, so it's pretty strong. And can you see how I've ground it so that it's like a radius here? So it's not like an end mill, because an end mill, you can't plunge down. You have to ramp down. On this one here, because of how it's sharpened, it's kind of like a drill. I can drill straight down. So this was handy, very handy to make that hole. I could have used an end mill, but this worked great. And then I took an end mill. It's a 1/4-inch end mill. And I went around and I made it basically a rectangle. So now I had space for the chain tensioner. I discovered that the plate was at a slight angle. It was 50 thou higher on this side because of a miscalculation, you might say. So what happened is, this is the space around it. I got 16, 16, I got 24, and I got 8. So I need to move the plate this way here. That was an error on my part, so I had to fix that up. I had to put it back into the mill. I had to dial up, move the table 7 thou. It's actually, the arrow should be pointing that way. I made a bunch more chips. There was a lot of chips being made. And then I started the process of hand filing to make the final shape. And I didn't always know what the final shape was going to look like. It kind of evolved as it went. And I'm doing a little bit more filing here on these posts. I got it up in the rotary table, and I'm rounding the corners here, things like that. This was the last operation in the mill. I got a 1/4-inch end mill, and I'm milling a flat there. That's for the chain clearance, because that's the upper part of the mount. So that's basically what happened in 3 days. Here's the piece. You can see here that, you know, some of these places I used the mill. Here I used the carbide burr to make that radius. This is the little post that goes in that holds the chain tensioner. Can you see how that just fits down like that? Now, what I told you previously is that, see that there? I was going to use a little plate and a couple screws, and I know apparently when I sketched this out, these are left-handed threads. I never even thought about it. I've been doing this basically my whole life, putting marks on that way, and 2 people said, "Oh, you're drawing left-hand threads," whatever. So what happens here is that I don't need that little plate, because look, this goes on over top, and the plate that holds the stator is going to hold that down. So I kind of modified as I was going, and then out of Delrin I made this. This is the chain tensioner, so it fits in like that. And it's a little bit of a snug fit, so I put it in the vise. And I just press it in like that. So there you go. You got a chain tensioner now. You've got a screw for adjustment. How this works, how it fits together. Here's the back of the clutch. Then we put this on. It's kind of neat how it all fits together. I'm kind of happy with this. There we go. Okay, this is the primary chain, and I got 4 of these. They're all used, and this is the one with the least amount of slop. A tiger cub has no chain, has no tensioner. Can you see how much slop there is? There's just oodles of slop. So this fits on like this. There it goes, just like that. I'm going to put a couple bolts in so that you can see what goes on. So if I turn this now, you can see how the chain, see that? And if I do this, can you see how there's a little bit of slop there? Because you do need a little bit of play. So that's just about right. I'm very happy with how that turned out. I think last time we made this piece, and this is going to hold the stator like that. No, actually, this was supposed to replace this piece. And I thought when I was making this that I was going to have some pieces on the outside, like 3 fingers, and that's what would center this. That's what I thought. But then as I was making this, I realized that, no, I've got room here. So this hole here is larger than this hole here. So we need to make a new one of these out of 1/2-inch plate. You can see how it's large. This is 1/4, this is 1/2. There's going to be a piece that extends here that fits down into there. So I don't need anything on the outside. So this does 2 things. It locates, and it also holds down the pivot on the chain tensioner. So that's what we're going to do. In the comments, there was a few people that said, why didn't you just use a 1/4-inch plate and have some posts? Well, it's a space consideration because you have to be able to put on the cover on the primary chain case. So you see how that rounds down? That is basically the shape of the inside of the case. If I have a bolt like that, I can't put on the case. So I had to make it this way because I can't just use a plate with some posts. But anyway, thanks for thinking of stuff that could work like that. So we're going to lay this out. We're going to go to the bandsaw. I'll stop talking for a while, and we're going to make a piece that fits on here and holds the stator. We got some lathe work. We got some mill work. Welcome to the shop. I'm glad I didn't make that much tighter. There we go. So what happens now, I'm showing Mitch. See here on the back of this plate, see how there's a cutout? So we need to do the cutout. We have to make the 3 slots, and we have to tap 4 holes, and then it's basically ready for installation. I need to make some sort of a cutout here, because that's where it fits onto here. Can you see that? I don't think I have to go out so much, and what I'd like to do is to have a radius here, so I don't want that to be straight across there. We'll put a nice little radius in there. So basically this can just go up. You don't have to have that piece there. On the one side I will have to have a little bit of a space there. That's for the wires. So okay, I'll just make a mark with a felt pen, then I know what to aim for. It's going to happen in the mill on the rotary table with an end mill. So I'm going to cut away metal, but we're going to leave this, see this ring here? That's going to get left. So I have to machine down, but I want to leave that part there. And then we're also going to have a radius here for support. I have to drill through here. I'm going to use these as the drill guide, and then I know the slot. That's where the slot's going to be in here. It's going to be 3 slots, and we'll do that on the table, as on the rotary table as well. So I just put that on like that. Okay, so these are all the same center distance. So once I get one all centered up, the rest, all the other 2 should be good. So let's go make a slot. This is going to hold it's a slot for a 6mm Allen screw. Oh, cuts nice. This is a test. We're going to put this on here, see if the Allen screws go into the slots. That would be nice if it did. 2. 3. Okay, so that turned out pretty nice. I like that. So that's how we adjust the timing. When the time comes, we'll adjust the timing. There's one more thing to do. We just have to bolt on the stator. So I need to make up a spigot or something, an arbor. I've got some Delrin in the lathe. I know the size here because we want these two to line up. This is not an eyeball thing. There we go. So look at that. It fits all around. Okay, so this can't move because it's wedged in there a little bit. So I can just drill. I can drill those 4 holes right like that. It's not going to move because look at that. Everything's held. Thank you, Delrin. So let's go to the drill press. We're going to make some marks. We'll drill and tap some holes and we're basically done. Good feeling. Okay, first time. Let's see what happens. Okay, here's the rotor. I need to put a spacer under here. I know that. And then this is what's kind of crucial. Okay. Can you see how this is moving? Can you see how the space is changing? There, it starts to hit right there. So I'm going to have to, it's almost like the flywheel has a little bit of a bent shaft or something, so it is a 60-year-old motorcycle after all, or something like that, so I'm going to have to do a little bit of fine-tuning there, but basically, ignition is mounted. Hope you enjoyed watching this whole 3-part series. It was quite a bit of work. So Mitch and I like coffee. If you buy us coffees, that'd be much appreciated. Helps to fuel our channel. Take care. See you next week. Stay safe.